this chapter, I wanted to break the videos up a little bit more because it is pretty easy for these videos to take a really long time. So for the next at least 2 sections and maybe 3, plan on watching the retake even if you do well on the original. I'm just designing it so that the videos can be a little bit shorter rather than having like one 14-minute video can be pretty intense. So as we start this section, I first want to remind you what a system of equation is and what a solution to a system of equation is. So first of all, a system of equations, system means more than one. So this means more than one equation or line. For us in 8th grade, most often we're trying to find the solution to 2 equations, and the solution is where the lines intersect. And I would say if there's anything that I want you to remember about systems of equations 10 years down the road, it's that a solution to them is where the lines intersect. Now, when we're dealing with story problems, that obviously still means the same thing, but it's represented in a different way. In the last section, we learned how to find the solution to a system of equations by graphing both lines, which we did down here, and then finding the point in which the lines intersect. This section is going to teach us a new way to find the same solution, and it's called the substitution method. Now, the substitution method, if you notice the root word of substitution is substitute. So our entire goal is to get a variable by itself, something like y equals or x equals, and then our goal is to substitute that into the opposite equation to solve. So the first thing I noticed with our equations is that they are both in y equals or x equals. And the most important thing about the substitution method is you have to get a variable by itself. It doesn't matter which variable, just a variable by itself. Now, since we have these, I'm going to write one equation out. And so I get y equals 2x plus 2. Now, what I want to do is I want to take this variable and I want to replace it or substitute it with the opposite equation. Now, the opposite equation tells me that y equals x minus 1. Whatever x is, we want to do that minus 1. So what I now have is I have the first equation, except I have substituted y equals for x minus 1. And now, it feels a little weird. Looking at it, you're probably freaking out, but that's okay, because once you have this part done, the rest of the equation is stuff we've already done before. So now I just simply need to solve for x. So what I'm going to do is I'm going to subtract 2x from both sides, which gives me negative 1x minus 1 is equal to positive 2. From here, I'm going to add 1 to both sides. So I get negative 1x equals 3. I simply divide by negative 1, and I get x equals negative 3. Which is good because when I graphed it, I actually got the same x value that I got from the substitution method. So we know we're on the right track. Now, in order to find y, we have to take this value of negative 3, and we simply plug it into one of the 2 equations that we started with. It doesn't matter, and I'm going to show you why, but it won't matter either way. So if I plug it into the top equation, I get y equals 2 times negative 3 plus 2, and if I plug it into the bottom equation, I get y equals negative 3 minus 1. So the bottom equation here is obviously y equals negative 4. And the top equation, I get negative 6 plus 2, which also is y equals negative 4. So I got the correct answer both ways. I then found that my ordered pair was the same as what I had before. Therefore, my answer should be correct. But now I need to ask myself, how could I check to make sure my answer is right? And the solution to this is actually not too bad. We know that our answer is the ordered pair -3, -4. All I do is I plug it into each individual equation, if this is my x and this is my y, and make sure it gives me two true statements. So I plug it into the top first. I get -4 equals 2 times -3 plus 2, which is a true statement. That's true. Then I plug it into the bottom equation. Same thing. I get -4 for my y equals -3 minus 1. That is also a true statement. So my answer should be -3, -4, which means that's where the lines intersect. So now that we've covered the basics of the substitution method, I'm going to show you what it actually looks like. Now, you have to remember that I said the most important thing is get a variable alone. It doesn't matter what variable. It matters that you get a variable alone. So I'm going to go down here to this bottom equation where I have one x and one y, and I want to get one of those variables alone. In this case, I'm going to make x by itself by adding a y to both sides. Now be very cautious because these are, once again, boys and girls at a dance. I know you're all rolling your eyes, but you'll remember it. X equals y plus 4. We now have the variable x by itself. Once you have a variable by itself, you simply take that variable and we are going to substitute it into the opposite equation. So I'm going to write the equation 2x plus 2y equals 4. And what I have to do is I have to take this variable x and substitute in y plus 4. So I'm going to erase this to put 2 parentheses y plus 4. So I now have 2x plus 2y equals 4, which is what I had originally. I just now have to solve. I'm going to solve using the distributive property. So I get 2y plus 8 plus 2y, because this part stayed, equals 4. I combine these two things together to get 4y plus 8 equals 4. And now I just solve it like I've always solved it before. 4y equals -4. And then 1y equals -1. Now, once I have a variable solved for, all I have to do, so I'll solve for a variable. In this case, I solve for y. Step 3, which we do now, is you plug in to find the other variable. So in this case, I'm going to plug it into either equation, but I'm going to plug it into this bottom one. But you could plug it into either. So I'm going to get x equals -1, because that's my y, plus 4. And so I get x equals +3. So now I get the ordered pair 3, -1 as my answer. So the most important step of any problem is identifying if we're right or wrong. So what I'm going to do is I'm going to erase my work here at the middle, and I'm just going to check my answer. So I'm going to go back to the original two equations, all the way back, and I want to know, is my answer correct? So I know that 3 is my x value, and y is my, or -1 is my y value. I simply plug that into both equations. So the top equation, I do 2 times 3 plus 2 times -1 equals 4. That's 6 plus -2 equals 4. That is a true statement, so we know we're half correct. The second part is 3 minus -1 equals 4. Minus a negative is like addition. So it's 3 plus 1 equals 4. That is also a true statement.